Now, those are just the basic features, common features you'll see in a phase diagram. Phase diagrams can also show other solid phases, multiple solid phases, because substances are known to exist in more than one solid form. Okay, so if this is this represents a gas, right? This region, and this region represents a liquid. Okay, this would have to be a solid, right? If you see that extra boundary there, that means there's another solid phase there. So a solid can undergo transformation from one crystalline form into another crystalline form. So you could have multiple solid phases in a phase diagram. So what would the phase, what would be this point A, what would this point A represent? That would be a condition where you would find two forms of the solid in equilibrium. Okay, what would point B represent? Solid and liquid at equilibrium. Point E would represent liquid and gas. Point E would represent triple point where we have solid, liquid, and gas. Point D would represent another triple point, but this time you have two solids in equilibrium in the gas. Okay? I guess there's no point F there. So here's example. This is a phase diagram for mercury iodide looks like this. This is just an illustration. This is not drawn to scale. What phase is represented by point D? Solid, liquid, or gas? Let's make that a clicker question. Point D is what? A, solid, liquid, or gas? Solid, B, liquid, or C, gas? Point D represents gas. Very good. What about point C? Does it represent solid, liquid, or gas? Liquid, very good. Point B, solid, liquid, or gas? That would be a solid. Okay. And point A, solid, liquid, or gas? Also a solid. Okay. Now, according to this question, so A is a solid phase, represents a solid phase. Region B represents a solid phase. Solid mercury iodide is known to be red at room temperature and turns yellow. It's still a solid. It turns into a yellow solid when heated to 127 degrees. Which region of the phase diagram represents solid mercury iodide that is red? Is it A or B? Okay. It's red at room temperature. It's a red solid at room temperature. It becomes a yellow solid at 127 degrees. It's mercury iodide in both cases, just different crystalline forms or different colors. Which region of the phase diagram, A or B, represents solid mercury iodide that is red? What's room temperature? 20, 25 degrees Celsius. And so you heat it to 127. So if you have to heat something, what happens to the temperature? Increase, right? So you have to go to the right. So red when it's in region A. When it switches over to region B, you heat it enough, raise its temperature enough, switches over to region B, it becomes a yellow solid. And if you keep heating it, what happens to it? Eventually it melts, right? If you keep heating it, eventually it melts, turns into a liquid. If you keep heating it, eventually it turns into a gas.